Hi everyone. Consider this example, this transition diagram. This is epsilon NDFA. Now I want to convert this epsilon NDFA into NDFA. So for that purpose I will use closure property, and there are few points you have to remember. First point is, whenever you convert epsilon NDFA to NDFA, then the number of states remains same. Okay, and all the states which will reach final states with the help of epsilon moves are becoming now final state in NDFA. Okay, and the third is initial state is also same. Number of state is same, but the states which take epsilon moves to reach final state will now become final state in the NDFA transition diagram. Okay, so how can I convert this epsilon NDFA into the NDFA? For this, closure properties are used. So for every state I will use this pattern epsilon star 0, epsilon star 1, epsilon star. Okay, for every state. So A on reading epsilon star means taking closure property. So A on reading epsilon will go to B as well as will go to D state. So A on reading epsilon will go to B as well as will go to D. B on reading 0 will go to C. Okay, and D on reading epsilon will go to D itself. Okay, and here one more thing, whenever you take epsilon star, so one trivial thing added is A will go to A itself also. So here A on 0 will go to A itself. Okay, now 0 is completed. C on epsilon star means C on reading epsilon will go to, there is no move defined for epsilon here, so the trivial one is added. C on epsilon will go to C itself, D on epsilon will go to D itself, and A on epsilon will go to either A, either B, or either D. So these are the states which are added by constructing the transition table of NDFA, and on this transition table the state is A and the input alphabet is 0. What I mean to say, if you are present at state A and you read input alphabet 0, then the possible states which you are going to A, B, C and D. These are the possible states. So just note it down here. A on 0 will go to A, B, C, D. Okay. Now take the transition for input symbol 1. So first A on epsilon star will go to A as well as B and as well as D. A on input alphabet 1, there is no move defined for input alphabet 1. So here A on 1 is 5. 5 means dead configuration. B on 1 is B on 1. So there is no move defined for B on 1. So B on 1 is also 5. D on 1 is D itself. Okay. So here there is no move defined. And D on epsilon is D itself. So A on reading input alphabet 1 will go to state D. Okay. So just note it down here. A on reading input alphabet 1 will go to state D. Now consider the next state. Next state is B. So B on epsilon star will go to B itself, which is trivial, or will go to D state. B on 0 will go to C and D on 0 will go to D. C on epsilon star will go to C, only C. There is no move defined here. D on epsilon star will go to D. Okay, that means B reading after input alphabet 0 will go to either C or D. Will go to either C or D. Okay. Now B on input alphabet 1. So first of all, B on epsilon star will go to B as well as D. B on 1 will not go anywhere because there is no move defined here. So B on 1 is 5, which is dead configuration. D on 1 is D itself, and D on epsilon star is D. That means B after reading input alphabet 1 will go to state D. Will go to state D. So here B on 0 is C and D. B on 1 is D. Okay. Now the next state is C. So for every state you have to do this procedure to achieve the transition diagram of NDFA. Okay, so I have considered the state A as well as state B. Now the next state is capital C. Capital C on epsilon will go to capital C and nothing. There is no move defined here. Capital C on 0 will go to nowhere because there is no defined here. No moves defined here, so it is 5. So C on 0 is 5. Now C on epsilon star will go to C, and C on 1 will go to B, and B on epsilon will go to either B or either D. That means C on 1 will define B as well as D. Okay, so here C on 0, 5 as C on 1, B as well as D. Now the last state is D. D on epsilon is D, D on 0 is D, and D on epsilon star is D. That means D on 0 will go to only D. Similarly, D on epsilon star is D, D on 1 is D, and D on epsilon star is D. That means D on 1 will go to only D state. So here D on 0 is D, and D on 1 is D. Okay. Now our task is over. The final is using this closure property. I get all the moves of all the states for input alphabet 0 and 1. Now the final one is making the transition table. So we have two input alphabets 0 and 1, and we have 4 different states A, B, C and D. A is the initial state and D is the final state. A on 0 is A, B, C, D. A on 0 is A, B, C, D. And A on 1 is D. B on 0 is C, D. B on 0 is C, D. And B on 1 is D. Similarly, C on 0 is 5, that means that configuration, and C on 1 is D, not D. B and D. Now the last one is D on 0 is D, and D on 1 is D. So this is the final transition diagram of NDFA. This is epsilon NDFA. I use the closure property to convert it into NDFA and make the transition table of NDFA. Okay. So in the next video, we will take one more example to convert epsilon NDFA into NDFA.